The last thing we need to add to our blogging app is a way for users to comment on blog posts. The first thing you'll see here in the top corner is I added a little link for home. That makes it a little easier for us to navigate around as we run through our app here. We're not going to look at that. That's a real simple link. So here's our view for our blog posts. We made one change to it, and on line 21 we are checking if the user is logged in, and if they are, we allow them to comment. So we've got a little form element and text area for that comment, and then they can save it. The route that we're going to hit is post/comment/post ID. So let's take a look at the logic for that. And here's our new route to handle commenting. First, we ensure that the user is logged in, and then we grab the ID of the blog post that they are commenting on. We grab the comment text, the current user, we pass these values to our new model comment, the create method, and handle the error. And then, we probably really, for a nicer user experience would do this with XHR requests, AJAX, whatever. But for now, we're not going to do that. We're just going to refresh the page. So if we click on a blog post here from our home page, we'll see the post, and we'll see an additional field here at the bottom of the screen that allows us to enter some comments. This is great. And then we can click save. We'll see the page refresh, and we see our comment as well as who made the comment. And that's pretty much all there is to comments. Seems pretty simple. So the thing you need to think about when working with something like a comments is that you have to decide, do we want to embed these comment objects within the blog post document itself, or do we want to use a separate collection to store these comments? What we've chosen here is to use a separate collection, and the reason for that is one of the caveats and gotchas working with a MongoDB document is when the document size continues to grow, that causes the document itself to be moved on disk. Whenever the allocated space is reached, the document is moved. And so, that's a lot of extra work that has to be done by MongoDB, and at scale that can be a problem. So we've just avoided that altogether. We're going to use a separate collection, a comments collection. And so let's take a look at our model that we have defined for that. Here's our new comment model. As you'll notice, we've changed one thing here. We've added a new plugin that we are using across all of our models now. Since each of our models defined a created property set to the current date whenever we save it, I just refactored our app a little bit and made that a plugin that we then implement a little bit lower in the file. I'll show you that in a second. Comments are pretty straightforward. We've got a few properties. One is the text the user entered. We want to trim that. We want to validate that the string length of the comment is less than 250 characters long, just so that nobody, decides to upload, an entire encyclopedia or something in there and ruin our app for a moment. That's something to think about whenever you're defining your models. So we've got a couple other properties here. Post is the object ID for the blog post itself, and we're defining an index on that property as well. And the reason for that is because we're going to be querying on the post property later on when we load a blog post. So another word about this index field here is when Mongoose starts up, when you connect first to MongoDB, all the indexes defined in your schemas are sent to MongoDB as ensure index commands. And this is great for development because you can define your indexes and just move forward. But in production, something you want to think about is disabling that so that you don't accidentally create an index on some massive pre-existing collection and cause performance problems. So you can disable that for production here on line 19. You can set the schema option auto index to false, and it will not create the indexes for you automatically. The last thing is just storing the author so we know what to display later. We know who wrote the comment, and so we can give them a hard time later when we don't like what they said. And here on line 22 we're using that created date plugin, and that's about all there is to our comment schema. To display the comments in our blog post page, we need to look them up. So I've made some adjustments here to our route, and on line 35 we are using a new method we've defined on our model called find comments. That uses the blog post ID, and it creates a query and returns it, which allows us to customize the query. In this case, we want to sort by the created date, so we keep them in order, and then we're going to exclude the ID, which is a special syntax here for Mongoose that lets you exclude properties. And then we're going to execute the query right away, but we're not passing a callback. And when you don't pass a callback on an executed query, it returns a promise. And if you're not familiar with promises, I encourage you to look them up and read about them. Specifically, check out the Promises A+ spec. That's what Mongoose is compatible with. Anyway, it's a nice tool to know about and utilize in your apps. That's pretty much the only change here to our route. The only other real thing is that we're going to pass that promise then to our view engine, and Express Mongoose will kick in to wait until the promise is resolved before rendering. Let's take a look now at our new method, find comments, that's part of the blog post model. So now we're taking a peek at the find comments method we defined in our blog post model, and all it does is accepts an ID and a callback. We create a query for comments, and we want to match any post with a matching ID, and then optionally accept a separate parameter callback. If we don't pass the callback, what you'll notice here is we're returning this statement. If we don't pass a callback, we return the query object that's created. If we do pass a callback, Mongoose executes that query, and then it returns a promise. And so by using this sort of signature, we allow for the same behavior that you would get from the built-in methods that Mongoose has. You know, the callback behavior. When you pass a callback, it executes. When you don't pass a callback, you get a query back. So the last thing we need to look at then is we need to clean up the old comments. And we could have put this logic in our route itself, but that could get messy because as our application evolves, who knows how many different places we'll be deleting blog posts from, and we would have to copy this cleanup code everywhere. And why do we need to clean anything up in the first place? Well, that's because we had chosen to store our comments in a separate collection from the blog post itself. So what we're going to do though is handle all of the cleanup within our schema code itself. And we're going to again utilize this Mongoose Lifecycle module, which gives us a little bit of a nicer, fancy API for handling events. And the event after remove is now emitted on our model itself whenever a document is removed. So it is passing the document that was removed to the function, and what we can then do is just grab the comments and remove any comment with a post matching that post ID. Then we execute that, and if there's an error, we'll just log it to our console. And that's good enough to clean up anytime a blog post document is removed. And that about wraps up our simple tutorial for getting started with Express and Mongoose. Feel free to follow Mongoose for updates on Twitter at MongooseJS, and definitely check out the expressjs.com and mongoosejs.com websites for documentation and tons more examples.